Alright guys, this is like my first little video for fluid mechanics, but this is like a quick little overview of like what you guys learned on the first week. So I just put a bunch of formulas on here for you guys. The first formula right here is, you see that little weird fish looking sign? That's a specific weight. And you got gravity for English and SI. You have the specific weight of water, density of water, and these are just a bunch of overview formulas. Liquid that is has a mass of 500 kilograms and a volume of zero point 0.9 meters cubed. And in this question, I'm going to find the density, specific weight, and specific gravity of this question. So to find the density, first, you would use the formula mass over volume and use that given mass, 500 kilograms, divided by 0.9, which is the given volume, which will give you the density. And hold on, I'll be right back. I forgot to get my calculator. All right, I'm back. So that answer will be divided by 0.9 would be 555.55 kilograms over meters cubed. And after that, since you have the density, you're now able to solve for the specific weight. And the standard specific weight formula is density times gravity. But in this case, since we're using SI units, you're gonna have to use the SI version of gravity, which is 9.81. And you will just do the given density that we found times 9.81 SI, which is 540, 50, and you get newtons over meters cubed. All right, now that we found the specific weight, we can solve for specific gravity, which is just the ratio compared to water. It's like a ratio of the liquids compared to water. In this question, you can find specific gravity two ways: with the density or specific weight. I'm gonna use the density version because I found the density first. And at this point, it's just plug and chug, but you have to know the density of water at SI units since we're using SI, which is just 1,000. And you would get 0.55. And by the way, if you get a SG of 1, that means your liquid is water. All right, so the last part of this video, I'm gonna do question 1-17 in your book. I'm not sure if this is your homework or not, but it doesn't matter. I'm about to do it for y'all. So in this question, you guys have like a mixed liquid that's like kinda mixed with gas and kerosene, and you're given the total volume, which is 12 feet cubed. The volume, that's gasoline in the liquid, which is 8 feet cubed, and the kerosene, which is 4 feet cubed. So this question is asking you to find the specific weight mixture and the specific gravity of this. So the first thing you want to do in this equation is, use like your formulas so you can make it easier on yourself and solve for the unknowns. So if you're given your total volume, you know that you're going to use this weight over volume equation to solve for your specific weight. So what you have is this, but you're missing your weight, so you have to solve for your weight. But you can solve for your weight by using this formula, which is basically just rearranging this. But since this is a mixture, you also have to include both of the densities in this problem. So you're gonna have to include the density of gasoline, your gravity constant, which is 32.2 because it's an English problem because you got feet cubed, and the volume of gasoline, which is, it says it's 8, and you add it together with the other mixture, which is kerosene, 32.2, and it says this point is 4. These two values of gasoline and kerosene you could find in your textbook, which is in the table in the back of the textbook. I don't know it at this time, but in fact, I'll be right back. I'm about to go look it up. All right, I went ahead and looked up those constants for that. My bad, I'm just trying to fix this camera angle. Which is 1.41 for gas and 1.58 for kerosene. I put G's for the gravity constants because I'm not gonna lie, I was a little lazy to keep on writing that. So I basically plugged all that into my calculator and I got a weight of 566.72 newtons. And now I can solve for my specific weight of this mixture, which is 566.72, which is again your total weight, and divided by 12, which is your total volume, and you would get 566.72 divided by 12, which equals 47.226. So now that you have that, you could solve for the specific gravity of it, and you just compare your mixture of your specific weight divided by water, which for water for English, I believe it's 62.4 on top of my head. So I would just do 47.226 divided by 62.4. Again, guys, I'm sorry for the handwriting. I'm kind of just stalking through this work. Oh, my bad. But it's right here at the edge of the corner on the right side. And your answer would be SG equals 0.75. All right, and that's it for this video. Next time I'm gonna make a video about pressure and the relations of pressure as it goes up and down through tubes called manometers eventually. And manometers, my bad. And also like pressures in like tanks.